All right, so for 33, 3 times 4. Four to the 2x minus 1 plus 4 equals 14. All right, what you got to do is you got to isolate. You got to get rid of the 4 at least before you do anything. You don't want to take the log of anything at this point. See what you can simplify. So subtract 4, and I get 3 times 4 to the 2x minus 1 equals 10. All right, question. Can we divide by 3? And if we can, does it make sense? Okay. Can we divide by 3? And then should we? Alex, can we?
I guess you can divide by 3.
You guess?
Yeah.
Then you probably don't know the second part of it. Does it make sense?
It doesn't make sense.
It doesn't make sense. Either way, it doesn't hurt. Now, you can't write it as a decimal. Here's why you can. As long as you don't have a power, like if that's 10 to the x or there's a power over there, you don't want to divide. You don't want to mess with it. But if you're going to divide it into a constant, it'll be okay. Don't have to. You don't have to. Did anybody divide by 3? 1, 2. All right, just a couple people. 3. So if you did that, you'd be fine. Now, what if I take the log right here? Let me just take the log right here since only a few people did. If I take the log of 3 times 4 to the 2x minus 1 equals the log of 10. Not that I have to do anything, but what's the log of 10 equal? Equals 1. You can replace that with a 1 if you want to. Absolutely don't have to, but you can. All right, but how do you treat this? This is probably where I see mistakes. This is a product. When you take the log of a product, it becomes a sum because the sum of the individual parts. Log of 3 plus the log of 4 to the 2x minus 1 equals log of 10. Subtract log of 3. So I'm going to do a couple steps at once. Subtract log of 3, so I get log of 4 to 2x minus 1 equals log of 10 minus log of 3. Now this 2x minus 1 has to go out in front. Log of 10 minus log of 3. And now distribute your log of 4. And when you do that, okay, multiplies both of them. So that just becomes 2x times the log of 4 minus 1 times the log of 4, which is the log of 4, equals log of 10 minus log of 3. Okay, and now, all right, I only got one term with an x. I got to add the log of 4 over. So I get 2x log of 4 equals log of 10 minus log of 3 plus log of 4. What do I divide by? Okay, what do I divide by? Same.
2 log of 4.
2 log of 4. Okay, so that's all being multiplied. It doesn't matter that the x is like right there in the middle. You're just going to divide by 2 log of 4. Okay, 2 log of 4. All right, and then that better give us the answer. Okay, so I'm not going to go through the rest of that. I'll let you do that. Okay. All right, if you missed any others or you got individual questions, let me know because we should have a little bit of time here. I want you to give a little bit of time to work on a couple things to prepare for the test. But that's how you do that one. You can't take the log of this the way it's originally written. And if you divide it by 3, okay, might have cut out a couple steps. Okay, but it'll still work. All right, so that was 33. Hold on here. Let me see where we're heading. Okay. We are going to, this was the one little thing we didn't get to yesterday. We had to do 2 things. So go ahead and get out something for notes because I don't have guided notes for you. not really necessary today. And we'll use your book here in a minute. Okay, we will need your book here in a minute. And this, like I said, another log fact. Okay, we have a bunch of properties we use. We got the power property, the quotient property, product property. This one's kind of common sense, but we still need to list it. It's going to come up here in a second. If you have two logs with the same base and they're equal, well, then M has to equal N. Okay, I think that's common sense. Now, IFF, that's math terminology, means if and only if. Okay, so that's not a typo. It means if and only if, so we can go either direction. This first one's pretty straightforward. We solved equations where we had some pieces yesterday where you did not have, everything didn't have a log. So we needed to isolate the log. Well, here, every term will have a log. When that's the case, once they're equal, now this is base 10. All you got to do is say x minus 3 equals 12. Okay, and that's it. And then add 3, you get x equals 15. You don't want to convert this to exponential form because every piece has a log. Okay, so that's a little bit different from yesterday. If I had the log of x minus 3 equals the constant 12, you would say 10 to the 12th power equals x minus 3. You'd have to write it like that. If they both have logs, then once they're equal, I can just drop the logs. So take a look at this. 2 log of 4, base 4 of 4 equals log base 4 of x plus 3. Okay. Before you set anything equal, I can't have that 2 in front of there. I got to take care of that. That'll become an exponent. So it becomes the log base 4 of 4 squared equals the log base 4 of x plus 3. Now, 4 squared is 16. You can say 16 equals x plus 3. Subtract, I get x equals 13. Make sure we don't take the log of a negative number. Okay. All right, I need to do one more here because if I don't, it won't be good. So let's take a look here. This third one. Let me throw this in here. Log base 3 of x plus 1 plus log base 3 of 2x equals log base 3 of 3x plus 1. All right. Think about it. Does every piece have a log? Every piece has a log. So what you gotta do is you gotta condense it until you get 1 log equals 1 log. Well, on the left-hand side, we got a plus. Remember how we condensed that? That becomes a multiplication problem. It will become log base 3 of x plus 1 times 2x equals log base 3 of 3x plus 1. Okay, so you got to condense that. Now, log base 3 of something equals log base 3 of a second thing. Set those equal. And yes, you can distribute that 2x. Or at least for the first part, I'm going to put the 2x on the outside. All right, now you no more logs. You just got an equation. You got to figure out what you need to do to solve it. So distribute the 2x, and I get 2x squared plus 2x equals 3x plus 1. All right, you're going to have a quadratic, set it equal to 0, see the factors. Okay, go ahead and do that. Now, I would keep my 2x squared positive. That's just me. Just easier for me. All right, so we get 2x squared. Subtract 3x. Minus 1 equals 0. That does factor into 2x in x. And I believe we need to both. No, one's positive, one's negative. No, it's not minus 3x. It should just be minus x, correct? All right, so that looks a little better. So this becomes a minus 1. This becomes a plus 1. Okay, and so I get x equals negative 1/2. X equals 1. All right, what do we have to check, though, when we're dealing with the logs? You're substitute back in. You can't take the log of 0 or a negative number. Well, either one of these result in a negative number. Yeah, the negative 1/2. So the negative 1/2 we have to eliminate. So your only answer is going to be x equals 1 here. Okay, for that. X equals 1. All right, turn to page 459. We were going to do this one earlier. We kind of pushed back a little bit of time, but we got to make sure we hit it. So I want you to look at number 117. Read through that one. Page 459, number 117. Okay, this formula right there, that is Newton's law of cooling. You will not have to memorize that. I will give that to you. Copy that down, though, and I'll explain what the pieces are. So T equals T sub S plus, in parentheses, T sub 0 minus T sub S e to the negative KT. So now this works when things cool down or things heat up based upon surrounding temperature. So if you take a cup of hot coffee and you put it outside, or you put it in, it's going to cool down to room temperature or whatever the temperature of the area is. If you take something cold, if you take a popsicle out of the freezer and you set it on the counter, it's going to move. It's going to increase temperature till it gets to room temperature. Okay. If you take a dead body at 98.6 and it's left in a field at 20 degrees temperature, it's going to eventually cool to 20 degrees temperature. So that's how they determine time of death and different things. So T sub S is the temperature of the surrounding area, or the constant temperature. Okay, so that is the temperature of the surroundings. T sub 0 or O, that looks like an O, is the original temp. Original temp. Okay, for that. K is some constant. K is some constant. All right, so if you take a look at that one, 117. So we're going to take a thermometer is taken from a room at 75 degrees Fahrenheit to the outdoors where the temperature is 20 degrees. The reading on a thermometer drops to 50 degrees after 1 minute. All right, so what is the T sub S and what is the T sub 0? Okay, what's the original temperature of the thermometer? 75, right? What's T sub S, the temperature of the surrounding area? 20. All right, so T sub 0, I'm just going to list it over here, equals 75 degrees. T sub S equals 20 degrees. Now they're going to give you a scenario. You're going to use that to find K. First thing we want to do is we got to find what the K value is. Okay. Now they say after 1 minute the temperature is 60 degrees. So that is where this T here is. It's basically the temperature after T minutes. So T is the temp after little t minutes. Got a lot of T's here. Okay. Well, what did they say here? What's the temperature after 1 minute? Is it 60 degrees? 50? So for T, little t equals 1, big T is 50 degrees. All right, what we're going to do is plug everything in to where it goes, and we're going to find K. We're going to put everything in where it goes, we're going to find K. So the temperature is 50 degrees equals temperature of the surrounding area, which is 20, plus the original temperature, which is 75, minus 20. E to the negative K times 1, because my time is 1 minute. All right, now there's a couple of little areas you got to watch. People make mistakes. I'm going to do a little bit of simplifying. So 50 equals 20 plus 55 e to the negative K, because 1 times K is K. All right, where are we going to go from here? Where are we going to go from here? Okay, think about it, what we need to do. Now eventually here we're going to get converted to natural log form. Give you that idea. You cannot, first of all, you cannot add 20 plus 55 and get 75 because the 55 is being multiplied by that value. This would be like 20 plus 55x, and absolutely not can you say that is 75x. That is first temptation. People want to do that. Cannot do that. All right, so you got to keep this separate. Subtract 20. Subtract 20. And so I get 30 equals 55 e to the negative K. To convert to natural log, I want to get e by itself, e to that power by itself. So get rid of the 55 by doing what? Dividing. If it gives you a decimal, just keep it as a fraction. So I get divide by 55, divide by 55. Now that'll reduce. You can reduce it or you can leave it as 30 over 55. It doesn't matter, but I think it becomes 6 over 11 equals e to the negative K. Convert to ln form. The natural log of 6/11 equals negative K. And what do I need to divide by to find K? Negative 1. Now you need to keep K as a exact value or round it. I think we usually have it rounded to 6 places. Okay, just to make sure we have it accurate enough. So go ahead, let's round it to 6 places. And we're going to use that for the rest. ln 6 divided by 11. And then, all right, so that's a negative. And when I divide by -1, I get a positive. So 0.606136. 0.606136. Okay. All right, so that's before we can even solve anything. We're not going to do all the pieces. We're just going to do after part A. We're just going to do after 5 minutes. Okay, after 5 minutes. So let's find the temperature. After 1 minute, the temperature is 50 degrees. So we're just going to do that first one there. So we're going to find the big temperature when little t is 5 minutes. Everything else is going to be the same. I just rewrote my formula so I had it in front of me. And you're just substituting in to find that big T. So there's really nothing to solve for other than just plugging in your calculator. So temperature equals the surrounding areas, which we said was, what was that, 20? 20 plus 75 minus 20 e to the negative 0.606136 times 5. See what you get. See what you get. Nearest 10 is fine. Just round the nearest 10. I don't know what the book has it rounded to. Yeah, there's 10. Madison, you got it?
I got 22.7.
22.7 degrees. I agree with that. 22.7 degrees. All right, so we're good. All right, so I want to hit one of those. And we'll hit another one probably on Monday. Okay. All right, a couple things I want to go over before I give you a little bit of time here. When I wasn't here Tuesday, you copied this down. This will be on the test. Let's go through it again. You're going to have to prove that property. Okay. Now, here's the deal, though. You're not going to be given that first step. This is all it's going to say. It's going to say prove log of m times n equals log of m plus log of n. Okay, so that's all it's going to say. Be the first question on the no calculator part, and then you're going to have to go do that proof. It's going to be worth 6 points. There's 6 steps. You got to have every step. Can't miss one. So this would be step 1. You don't need to number them. If it helps you, fine. So we're just letting x equal log of m. We're letting y equal log of n. Okay, once you got that, convert each piece to exponential form. Okay, what base are we in? Base 10, right? There's no base listed, so base 10. So exponential form. Make sure we're good on that. What's that going to look like? Carlos, what do you think? What's exponential form going to look like?
Not sure.
What's my base?
10.
10. It's going to be 10 to what power?
X.
10 to the x equals what?
N.
Good. 10 to the x equals m. Okay, if you think, I know it's nor will it ever be written in there, but that's just what's going on there. You always start with the base, you go to the exponent equals the m. And 10 to the y equals n. Okay, within my problem, I got to have an m times an n. You got to multiply that. So what I'm going to do right here is I'm going to say, all right, m times n is equivalent to 10 to the x times 10 to the y. I just taken from that step up above. If I multiply m times n together, since one of them equals 10 to the x, the other one equals 10 to the y, that has to be a true statement. M times n, okay, if I multiply those two together, it has to be equivalent to 10 to the x times 10 to the y. Our exponent properties, 10 to the x times 10 to the y, if I got the same base, you can add exponents. That becomes 10 to the x plus y. Okay, now from here, convert back to log form. Think about that. Convert back to log form. And what's that going to look like? The answer to a log is always the exponent. The answer to a log is always an exponent. So, okay, you can still do your swoop if that helps you. You're going to say log of base 10, of m times n equals the exponent, which is x plus y. Now we are done after this next step because we said x at the very beginning was what? Log of m. And we said y was log of n, so I can replace the x with log of m. Plus log of n. And we are done. Okay, so there's. So you're going to need to know that.
Scroll up real quick.
Yep. Is that far enough?
I want to see what the wording of the proof is.
And then you get that prove log of m at the end. So that first one, let x equal log of m, let y equal log of m. And then we go convert to exponential form, rewrite it as a product, m times n equals 10 to the x times 10 to the y. We use our exponential rules, convert it back to log form, and then that's why that works. That's why that works. Okay. Like I said, I wanted to give you some time. We'll go over a little bit more details on the actual test. Like I said, 2 parts. No calculator, graphing calculator. Whatever you don't get done is homework. You know, you need to do this. I have the answers here. They'll be on Canvas so that you have an idea if you're getting these right. From there. So work till the end of the period on this. If you missed some questions from the homework, weren't quite sure, this is a good time to maybe get them answered. I think for 38 and which one is it? 38 and 42 lists exact values as well. Okay, also list that. All right, I'm going to do a couple things here, and then I will list the answer or put these up so you can see them.